All right, now it's time to go over the study guide for your Unit 3 test. Remember, the study guide is laid out exactly like the test, pretty much word for word, the same questions as the test with different numbers. All right, so for example, number 1 here will mimic number 1 on the test. Number 2, when we get to that, will mimic number 2 on the test, so on and so forth. So let's get going here. So select all expressions that are equivalent to 56 to the power of 2/3. So what we're going to do here is we're going to rewrite this in roots form. So this is an exponent form. We want to write this in roots form. Okay. So in other words, we want to write it like that. Okay, so you might remember way back from the beginning of this unit, all right, we talked about fractional exponents, okay, and we talked about what the numerator and the denominator means of that fractional exponent. So in case you forgot, I'll write it over here. The denominator tells me the type of root. So the denominator tells me the type of root. In this case, the denominator is 3, which tells me this is going to be a cubed root. If the denominator was 2, it would be a square root, so on and so forth. The numerator tells me the exponent. Okay, so in this case, the numerator is 2, so the exponent is going to be 2. But here's the key. The exponent can go inside or outside the root symbol. So I can write it inside like this, or I could write it outside the square root, like this. Okay? So that is how we write it in a roots form. Now, which one matches up with this? Now, this first one here looks like it matches up with A. Okay, so this one is A. Okay, and this one looks like it matches up with D. If I added parentheses right here, which I could, this would match up with D. So the answers here are A and D for number 1. Okay. Let's look at number 2 now. For each of the following quadratic equations, right, find the value of the discriminant without actually solving them. Determine whether it has 0, 1, or 2 real solutions. Okay, so this goes back. This actually is the most recent thing we did in lesson 19. Remember, the discriminant is the b squared minus 4ac. That is is the part of the quadratic formula that is under the square root. All right, so that's how we find the discriminant. And what we learned is if the discriminant is negative, that means it has, let's actually start with positive. If the discriminant is positive, if it's greater than 0, then it has 2 real solutions. Okay. If the discriminant is equal to 0, that means it has 1 real number solution. And if the discriminant is greater than 0, or greater than, if it's less than 0, so if it's negative, that means it has 2 complex number solutions. In other words, 0 real solutions. Okay? So that is how we base our decisions off of. So let's first find the discriminant of each of these. So I'll first identify A, B, and C. for each of them. So for number 1, it looks like A is going to be 1. B is going to be -4. All right. Let's make this a little neater. All right. So A is going to be 1. B is going to be -4. C is going to be 1. Okay, for number 2, for the middle one, A is going to be 1. B is going to be -4. And C is going to be 4, the constant term. And for the third equation, A is going to be 1. B is going to be -4, once again. And C is going to be 10. Okay, so remember, b squared minus 4ac, that is the discriminant. So for the first one, that's going to look like this. B squared minus 4 times a times c. Okay. So in this case, -4 squared, so that's -4 times -4, that's 16. And then that second part, okay, so this part right here, that's going to be -4 times 1 times 1. So -4 times 1 times 1 is -4. So 16 minus 4 is 12. So my discriminant for the first equation is 12. All right, for the middle one, the discriminant is going to look like this. So b squared minus 4 times a times c. So -4 squared is going to be 16. And then -4 times 1 is -4. Times 4 is -16. So 16 minus 16 is 0. So my discriminant for the second one is 0. All right. Excuse me. And then for the third one, all right, that's going to be, let's see, b squared minus 4 times a times c. So again, that's once again -4 squared. That's going to be 16. Then I have -4 times 1 times 10. So -4 times 1 is -4 times 10 is -40. So 16 minus 40. 16 minus 40, that's going to be negative. It's going to be a -24. Okay? So that's the value of the discriminant. How many real solutions to answer the second part? Well, the first one had a positive discriminant, so that means it's going to have 2 real number solutions. Okay? The second one, the middle one, had a discriminant of 0, which means it's going to have 1 real solution. And then the third one had a discriminant of -24. It had a negative number, so it's going to have 0 real solutions. Okay? All its solutions are going to be complex. Okay? That is it for number 2 on the study guide. Okay. Let's look at number 3. Okay. I'll zoom in a little bit on this. So find all the solutions to the following equation. X minus 8 squared equals -25. This one is very simple. All we need to do is square root both sides. Okay, square root both sides. All right, so I can do that to get rid of this squared here. So if I square root both sides, okay, so remember, the reason we square root is because square root and squared cancel each other out, leaving me with x minus 8. And on the right-hand side, the square root of negative 25. If it were the square root of 25, we would say it was plus or minus positive or negative 5. But because it's a negative 25, we're going to say it's plus and minus positive and negative 5i. So x minus 8 equals positive negative 5i. All right, and I'll finish it off by adding 8 to both sides, and I end up getting positive and negative 5i plus 8. Now, I can guarantee you, if this were a multiple choice question, you would not see this as one of the choices. Okay, remember, it's got to be in the right order. So with a complex number, okay, it's the real number goes first, followed by the imaginary number. In other words, the I term. So to write it in the correct order would be 8, positive 8, plus and minus 5i. Okay, so this is our solution here. Our two solutions are 8 plus 5i and 8 minus 5i. So if this were a short answer question like it is here, would I have boxed in right here would be totally acceptable. If it were a multiple choice or a multiple selection, you would probably see one of the choices be 8 plus 5i and one of the other choices be 8 minus 5i. Okay, that is it for number 3. Okay, number 4. Okay, let P equal 3 minus 5i and Q equal negative 8 plus 2i. Compute the following. Okay, P plus Q, P minus Q, PQ. So we have two complex numbers, and all we're going to do is we're going to add them, we're going to subtract them, then we're going to multiply them. So let's do A over here. So if I add them, which is what A is asking to do, all I need to do, and I'll use different colors, is combine the real numbers and then also combine the imaginary numbers. So if I do that, if I combine the real numbers, 3 and negative 8 becomes negative 5. And then the imaginary numbers, negative 5i and positive 2i becomes a negative 3i. So part A is negative 5 minus 3i. Okay. Part B, we're going to do the same thing, same two numbers, except we're going to subtract them. Now remember, with subtraction, you have to do keep, change, or let me write it out. Keep, change, change when you subtract. Okay. So keep the first one the same. Change subtraction to addition, and then change all of the signs in the second one. So negative 8 becomes positive 8, and positive 2i becomes negative 2i. So keep the first one the same, change subtraction to addition, and then change all of the signs in the second one. Once I do that, I can do the same thing I did in part A, and I can combine the real numbers and the imaginary numbers. So my real numbers here are 3 and 8. So 3 and 8 becomes 11. And then my imaginary numbers are going to be negative 5i and negative 2i. So that's going to be a negative 7i. Okay, and that's it for B. Part C, I'm actually going to do up here since I have more room. Part C, I'm going to multiply. So remember, when I multiply, negative 8 plus 2y, when I multiply, I want to use the box method. And I also need to use the fact that I squared equals negative 1 when I simplify. So let's first box method. Let me separate this. So 3 minus 5i, negative 8 plus 2i. So top left is going to be 3 times negative 8, which is negative 24. Right, top right is going to be 3 times 2i, which is 6i. Bottom left is going to be negative 5i times negative 8. So that's going to be a positive 40i. And then bottom right, negative 5i times 2i. That's going to be a negative 10i squared. Okay, and if I put that together, I have negative 24. And then 40i and 6i is 46i minus 10i squared. All right, we are not done here because remember, we have to use this fact that I squared is equal to negative 1. So I have to take this last term. Negative 10 times I squared is really negative 10 times negative 1. I squared is negative 1. So negative 10 times negative 1 is positive 10. So if I drop everything else down, I end up with negative 24 plus 46i plus 10. And I can now simplify it further because now I have two real numbers here. A negative 24 and a positive 10. Negative 24 and positive 10 becomes negative 14 plus 46i. And that is the final answer for C. And that is it for number 4. Number 5. Solve the following equation, 5a. Okay, so we're solving an equation with square roots. So the first thing I need to do is I need to take that equation, I need to isolate the square roots. So in order to isolate the square root, in this case, I'm going to have to add 5 to both sides. So that gives me the square root of 3x minus 2 equals negative 1 plus 5, which is 4. Okay. Once I have isolated the square root, I can go ahead and I can square both sides. And the reason I can do that, once again, is square root and squared cancel each other out. So on the left-hand side, again, square root and squared cancel each other out, and that leaves me with 3x minus 2 and 4 squared. 4 times 4, that's going to be 16. Now I'm going to go ahead and solve this like I normally do. So I'm going to add 2 to both sides. 16 plus 2 is 18. Divide both sides by 3. So x equals 18 divided by 3, which is 6. Okay, for part A. For part B, explain why the equation, the square root of 3x minus 2 plus 5 equals -1 has no real number solutions. So in order to do that, we have to attempt to solve it first. So if I were going to attempt to solve this, I would have to once again isolate that square root. So in order to do that, I would have to subtract 5 from both sides. And I would end up with the square root of 3x minus 2 equals -1 minus 5, which is -6. That's a problem. The problem is this negative number here. Okay, we've talked about this before. When you take the square root of a real number, of a positive number, the answer can be positive or negative, right? But the answer cannot just be negative. So explain why the equation has no real number solutions. It has no real number solution because you cannot take the square root of a number and have the answer just be negative. Okay, so that -6, when I subtract 5 from both sides, this -6 messes it up. So why does the equation have no real number solutions? Because you cannot take the square root of a number and have the answer just be negative. Okay, so that is it for number 5. We're up to number 6 right now. Okay. Here is the graph of y equals the cube root of x. Use the graph to explain why there is only one solution for every cube root equation of the form cube root of x plus a equals 0, where a is a real number. So in other words, if I had the cube root of x plus 1 equals 0, or if I had the cube root of x plus 2 equals 0, or the cube root of x plus 3 equals 0, so on and so forth. If I were to solve that, why would I only get one solution? Okay, and it has to do with the graph here. Let's look at this graph. How many times does this graph intersect the x-axis? Okay, well, it only intersects the x-axis right here, right? It only intersects the x-axis once. So because it only intersects the x-axis once, it's only going to have one solution. Okay? That is why it only has one solution for every cube root equation. So let me write that out. The graph only intersects the x-axis once. So there is only one solution. Only one solution. Okay. So the important was the reasoning, but we also had to use the graph in our reasoning. And I did. It only intersects the x-axis once. All right. Let's look at part B. Solve the equation cube root of x plus 4 equals -3 without using a graph. Okay. So we can do that. The cube root is already isolated, so I can go ahead and I can cube both sides, right? Remember, cube and cube root cancel each other out. So cube and cube root cancel each other out, leaving me with x plus 4. And on the right-hand side, I have -3 cubed. So remember, that's -3 times itself 3 times. -3 times -3 times -3. That's going to be a -27. And then I will subtract 4 from both sides. And I end up with x equals -27 minus 4 equals -31. So x equals -31. For part C, we're going to do the same thing, but notice this time the cube root is only over the x. Okay? So this was notice the x plus 4 was under the square root, the cube root. But in C, only the x is under the square root, which means I need to first isolate that cube root there. How am I going to do that? I'm going to subtract 4 from both sides first. And I end up with the cube root of x, equals -3 minus 4, which is -7. Okay. Now I can go ahead and I can cube both sides. Right? Cube root cancels out cubed, leaving me with x. And then I have to do -7 cubed, which in this case, you're probably going to have to use a calculator. So that's -7 times -7 times -7. Okay, it actually ends up being -343. So x equals -343. And that is it for number 6. Last question, number 7. We're getting towards the end here. Okay, so Mike and Jake are trying to solve the equation x squared minus 8x plus 25 equals 0. Here is Mike's work. Okay, at this point, he got stuck, so Mike is solving this equation right here. At this point, he got stuck. Finish the problem for Mike by completing the square. So we are at the point where we have x minus 4 squared equals -9. So to finish the problem using the completing the square method, I am going to square root both sides. Okay, for the same reasons I've been talking about. So giving me x minus 4 equals the square root of -9. That's going to be positive and -3i. And then I'm going to add 4 to both sides, giving me x equals positive and -3i plus 4. But remember, I got to write it in the right order. I got to have real numbers first, imaginary numbers second. So that becomes positive 4 plus and minus 3i as my solutions. 4 plus 3i, 4 minus 3i. Okay. So that's part A. Part B, Jake decided to use the quadratic formula. Here is his work. Okay, so Jake gets down to this point. So let me make sure I copy it down correctly. 64 minus 102. Okay. Finish the problem for Jake by using the quadratic formula. So we're gonna pick up the quadratic formula from here. So this is going to be 8 plus and minus 60 square root 64 minus 100. So that's going to be a -36, right? Divided by 2. Okay. Keep going. 8 plus minus square root of -36. So that's going to be 6i, right? Square root of positive 36 is 6. So square root of -36 is 6i divided by 2. And now to finish it off, I am going to separate the fractions out there. So I write it in the right form. So 8 divided by 2 is 4, and 6i divided by 2 is 3i. And what do you know? I get the same answer. I end up with 4 plus and minus 3i. 4 plus 3i, 4 minus 3i. Should I be surprised that I got the same answer twice? No. Mike and Jake were trying to solve the same equation. Okay? They just used different methods. It shouldn't be a surprise that they got the same answer. Okay? So that is it for number 7. That is also it for the study guide for Unit 3. Hopefully this